Class, this is the last video in our discussion on section 6.4 in your textbook on inverse trigonometric functions. And so we're going to be picking it up at the top of page 16 in your note packet. And so again, we got to find the exact value of a mixed composite. We're going to find the exact value of the cosecant of the inverse cosine of 7/25. Well, immediately we recognize that 7/25 is not a number on the unit circle. So we're going to have to take a different approach to finding the exact value of this composite. So the inverse cosine of 7/25 is equal to some angle between 0 degrees and 180 degrees. So we're going to set the angle theta to equal the angle inverse cosine of 7/25. So from page 9 of your note packet, that means the cosine of the angle theta has to equal 7/25. And we know cosine is equal to adjacent over hypotenuse, or x over r. Because 7/25 is a positive number, we know theta is an acute angle between 0 degrees and 90 degrees. So we can use a right triangle to solve this problem. X is equal to 7 in this case, r is equal to 25, right? So the adjacent side x is equal to 7 units, the hypotenuse r is equal to 25 units, and now we just got to figure out the length of the opposite side, right, opposite to theta. So using the Pythagorean theorem, x squared plus y squared is equal to r squared. X squared is 7 squared, r squared is 25 squared, and when we solve for y, we get y is equal to 24. So the sine, in a right triangle up here, the sine of this angle theta is opposite over hypotenuse, right, y over r, which is equal to 24/25. Well, cosecant is the reciprocal of sine. So if sine of theta is equal to 24/25, then the cosecant of theta is equal to 25/24, right? I just flipped the fraction over. Well, theta is equal to the inverse cosine of 7/25. So if I replace theta down here with inverse cosine of 7/25, I have the cosecant of the inverse cosine of 7/25 is equal to 25/24. Well, the cosecant of the inverse cosine of 7/25 is what we were asked to find up here at the beginning of the problem. That's what we were asked to find, and now we've done that. So the cosecant of the inverse cosine of 7/25 is equal to 25/24. This is the answer to this problem. On the next page, we're asked to solve another mixed composite. We have to find the cotangent of the inverse sine of 2/3. Now, because cotangent is the outer function, right, we know that the value of this composite is going to be a number. Well, 2/3 is not on the unit circle, right? It's not a number in the unit circle. So this angle, the inverse sine of 2/3, we'll set it equal to the angle theta. The angle theta is equal to the inverse sine of 2/3. Well, from page 3 of your note packet, that means the sine of that angle theta is equal to 2/3. And sine is equal to opposite over hypotenuse, or y over r. Well, because 2/3 is a positive number, theta is an acute angle between 0 degrees and 90 degrees, so we can use a right triangle to solve this problem. Y is equal to 2 in this problem. R is equal to 3. We just got to figure out what x is. So by the Pythagorean theorem, x squared plus y squared is r squared. Y squared is 2 squared. R squared is 3 squared. And when we solve for x, we get x is equal to the square root of 5. Well, from our right triangle up here, the tangent of this angle theta is opposite over adjacent, or y over x, which is equal to 2 over the square root of 5. Well, cotangent is the reciprocal of tangent. So if tangent of theta is equal to 2 over the square root of 5, then the cotangent of theta is the reciprocal of this fraction, which is square root of 5 over 2. Well, theta is equal to the inverse sine of 2/3. So we can replace theta down here with inverse sine of 2/3, and we have the cotangent of the inverse sine of 2/3 is equal to the square root of 5 over 2. Well, the cotangent of the inverse sine of 2/3 is what we were asked to find up here at the beginning of the problem. And now we've done that. The cotangent of the inverse sine of 2/3 is equal to the square root of 5 over 2. This is the answer to the problem.